Hi, good afternoon, everybody. This is Mr. Shua coming at you. I'm making this video to show everybody how to use the DESMOS Graphing Calculator when you're doing the TestNav questions and eventually doing the SOL questions. So hopefully you can look at what I do here so you can see the steps on using DESMOS Calculator to answer most of these questions in TestNav and for the SOL. Anyway, enough talking. Let's just get into it. And let's see what we can do here. So we're in the TestNav practice for Algebra 1 for 2023 based off the 2016 Math SOL standards. Question number 1. What is the value of this expression when A equals 8, B equals 16, and C equals -4? Then they give us this expression here, 5 times the cube root of A minus C times the square root of B plus 9. And we have our answer choices on the left here. We can come over here to DESMOS and let's see how we can enter this. So we have 5. Then it says the cube root of C. In order to get cube root, you can simply type C, B, R, T. And you see we get a cube root there. And it says the cube root of A. A is 8. So I'm going to enter 8 there. Then it says minus, so let me put my minus in, minus -4. I just like to put it into parentheses just to make sure everything is clear. So minus C, which is -4, times the square root of B. In order to get square root, you can simply type SQRT. And you see you get a square root. And it says B is 16, so the square root of 16, and then it says plus 9, plus 9. Answer 35, so that would be answer choice B right there. Okay, let's go on to the next question. Okay, question 2. Which represents this expression in simplest form? And we have 15 parentheses x to the -2 all to the third power divided by 3 parentheses x to the -4 all being raised to the -3 power. So again, we can use our DESMOS. So let's pull our DESMOS back up. Let's clear out this previous information. And what we're going to do, we're going to enter this expression into DESMOS here. So let me put my division symbol. And on the top, I have 15 parentheses x to the -2 being raised to the third power. And that's being divided by 3 parentheses x to the -4. And that's being raised to the -3 power. Okay, if you look to the right here, you see DESMOS gave us a graph of what this expression is. So if we want to find which one of these matches it, all we have to do is just punch in the one that overlaps this graph. So let's try the first answer, 12 divided by x6. 12 divided by x to the 6th power. Well, that one isn't it, because you see it doesn't totally overlap it. And just to save time, I'm just going to go to the answer, which is D. And let's just check that. 5 divided by x raised to the 18th power. And you see it overlaps it. If I go back, you see it does that, but when I put the 8 in, that's it. So D is our answer. Okay, let's go on to the next question. Okay, question 3. What is the quotient of 15x squared minus 8x minus 12 and 3x plus 2? Assume the denominator does not equal 0. Whenever they say assume the denominator does not equal 0, they basically mean that you're never going to have 0 as an answer in your denominator. You're going to have a real answer. So let's see how we can use DESMOS to answer this one. So let's clear out this previous information here. So Let me go put into my division symbol, and let me put in 15x squared minus 8x minus 12, and that's divided by 3x plus 2. Okay, so we get that line there that we see on the right on Desmos. All we need to do then is just put in each one of these and see which one matches that line. So I'm just going to go to, I know that one's too big. That's not going to, let me try B here. So B says 15x squared minus 5x minus 10. So that one's not it. So, and in the interest of saving time, I'm just going to go for the one that is it. Let's look at 5x minus 6. Boom. You see, it overlaps it. If I take the 6 off, put the 6 back on, it overlaps. D is our answer. Okay, let's look at the next question. So here, select the correct answers when factored completely. Identify the factors of this polynomial. 9x squared minus 39x minus 30. Okay, well, first thing is the 9, the 39, and the 3, they all have a common factor. And let me, matter of fact, I'm going to show you something. I probably shouldn't show you, but do I have it on this computer? Oh, I don't have it on this computer. Oh, so never mind. I'm not going to be really showing you anything here. So let me just pull up Notepad real quick so I can take some notes. Okay, so we had 9x squared minus 39x minus 30. And then some of you may have recognized that 3 was a common factor to each of those terms. And if we divided each one of these numbers by 3, what we should get is 3x squared minus 13x minus 10. So we already have the 3 factored out. Now we have this 3x squared minus 13x minus 10. Hey, sometimes you got to improvise. Okay, so what we're going to do, we're going to go to our Desmos here. We're going to clear out our previous information, and we're going to graph that. Well, let's bring up our calculator here. 3x squared minus 13x minus 10. Okay, so on the right here, Desmos graph this for us, and we see that we have an intercept at positive 5 and negative 2/3. So positive 5 and negative 2/3. Okay, so let's deal with the negative 2/3 first. Okay, now how do we take the fraction and then convert it to an algebraic term? Okay, I've mentioned this previously. Your denominator, whatever this is, in this case it's 3, is going to become your lead coefficient, 3x. Then you look at this sign right here. Whatever this sign is here, you reverse it. Since that's a negative, we're going to have a positive. And then your numerator follows after your sign. So 3x plus 2, that's going to be our first, or one of our factors. Then we have positive 5 here. So positive 5, which is just simply 5 over 1, which is a fraction. And then again, looking at your denominator, so 1x, so simply it's x. Here we have a positive, so here this is going to be a negative, and then your numerator becomes your denominator, x minus 5. So the factoring of the 9x squared minus 39x minus 30 is the 3, the 3x plus 2, and the x minus 5. And if we go back here, yep, so the 3x plus 2, and the x minus 5. All right, great. Let's go on to the next question. Okay, let's look at the next question. All right, question 5. When x is greater than 0 and y is greater than 0, which expression is equivalent to the square root of 180 x to the 9th y to the 16th in simplest form? All right, so let's head over to Desmos and take a quick look here. And then I'm going to put in my square root, 180. And what I'm going to do is, instead of using x and y here in Desmos, I'm going to choose different characters. You'll see why in a moment. I'm going to put in a to the 9th. And then I'm going to put in, instead of y, I'm going to put in b. b to the 16th. And then you see it says add slider. Whenever you see the add slider, always hit the blue all button. So I have 2 sliders here. So what Desmos has done is it assigned values for my variables here, which is why I was able to come up with an answer. Now, what I suggest you do is change the numbers on the variables. Like I'm going to choose 2 for A, and then I'm going to just choose 3 for B. You can choose any numbers that you want to choose. I'm just making the numbers easy here. So with this square root of 180, a to the 9, b to the 16th, with this here, all we need to do is plug in whichever one of these matches this number here. So let's just try that first one here. So we have 3, but instead of an x, I'm going to put an a cubed, and then a b to the 4th, b to the 4th, and then square root of 20. So that's different. So that one's not it. In the interest of saving time, I'm just going to go to the one that is it. And let's go, we're going to go with D here. So we're going to go 6a to the 4th, b to the 8th, then the square root of 5a. There it is. See? The exact same number. So D is our answer. Okay, let's look at the next one. Okay, what is the cubed root of 3,456 in the simplest form? Okay, again, let us use Desmos here. We'll erase this previous information. So we want the cubed root of 3,456. So since we want a cube root here, actually what we're going to do, we're going to put in our division symbol, and we're going to put the 3,456, and that's going to be divided by x cubed, since we want our cube root. Then we're going to go to our gear icon, and then we'll go to our table icon, and we'll take a look at the different answer choices that we have. So here it says 2 cube root 12. Well, here in our table it says 2 cube root 432. So we know that 2 is not it. Let's take a look at 6. If I type in 6 here, it says 6 cube root 16. Now that looks like it might be the answer, but hold on. Let's take a look at 12 here. 12, we have 12 cube root 2. So both of these are matching so far. Then just to rule out 24, we'll just put the 24 in there. It says 24 and some decimals, so this doesn't answer. So both the 6 cube root 16 and the 12 cube root 2, they both seem to match. But how can we know which one is which? Well, simplest form. This cube root 16 is not in its simplest form, but cube root 2 is. And your answer is C, because the cube root of 16, this can be simplified even further. This can't. So C is your answer. All right, let's take a look at the next question. Okay, question 7. For which value of x does the cube root of x simplify to be the 5 cube root 7? Okay, let's go back to our Desmos here, and let's clear this out. So, if I put in 5 and then cube root, CBRT, 5 cube root 7. Oops, I put 3 cube root 7. Let me go change that. 5 cube root 7. We see it's this decimal here. So all we need to do is take the cube root of each of these and see if it gives us that decimal. All right, let's see. So CBRT cube root 35 is 3.2. Nope, that's not it. So CBRT 245. We get 6.2. Nope, that's not it. So CBRT 875. Yep, that's it. Exactly. So it's C, 875. All right, let's look at the next one. Okay, directions. Drag the answers to the correct boxes. Each answer may be used more than one time. Complete this equation to create a true statement. So we have 4 radical 2 times 2 radical 3. So anytime you have a question like this, the simplest way to answer this is just multiply the integers by the integers. 4 times 2. 4 times 2 is 8. So I take the 8 and put it right there. Then radical 2 times radical 3. Well, that's radical 6. So I'll simply put radical 6 right there, and you're done. So again, all you do is multiply the integers by the integers, multiply the radicals by the radicals. And then if you get a radical that needs to be simplified, then you would need to go further. Radical 6 can't be simplified any further. That is your answer. Let's look at the next question. Okay. Select the correct answer. Michelle correctly solved a linear equation, and the last line of her work was 1 equals 2. Which statement best describes the solution to the equation Michelle was solving? Well, anytime you have an equation and one side does not equal the other side, well, the answer is there's no solution because they don't equal each other. Now, however, if it was different, if it said 2 equals 2, they equal the same thing on each side, then in that case, the answer would have been infinitely many solutions. But since it's 1 equals 2, they don't equal, no solutions. All right, next question. Okay, what are the solutions to the equation 2x squared plus 5x plus 3 equals 0? So here's a quadratic. We can graph this in Desmos and see where the points intersect the x-axis here. So we'll just plug this in right here. So we'll plug in 2x squared plus 5x plus 3. Okay, let's zoom in, zoom out a little bit. All right, so we see that it intersects the x here at what, negative 1.5 and negative 1. So we have negative 1, negative 1.5. Well, I don't see a negative 1.5 over here, but let me see what I can do with, let's say, negative 1.5. And I get this circle here, so it's going to change this decimal into a fraction for me. Negative 3 halves. So that means I have negative 3 halves and negative 1. Here, answer choice C. Negative 3 halves, negative 1. All right, let's move on to the next question. Okay, type an inequality statement in the box. Use the less than or greater than for the inequality symbol. Solve for x. Okay, let's bring this up in Desmos here. Let's clear out this previous info. Put this back to home. All right, what do we have? We have 6x minus 11 minus 13x is less than 7 minus 5x. Okay, so 6x minus 11 minus 13x is less than 7. All right, so Desmos is showing us a shaded graph, and it's on -9, and then it's shaded up. So it looks like x is greater than -9, because -9, everything below that is not shaded. So the shaded region goes from -9 and up. So therefore, x is greater than -9. All right. So next question. Direction, select array, then drag the endpoint to the correct location on the number line. Graph the solution set to this inequality. All right, let's bring up Desmos again here and clear this out. So it says the negative, per open parentheses, x plus 4, close parentheses, minus 2 is greater than 2x plus 6. Okay, so this time Desmos is shading to the left, and it looks like it's at -4. So it looks like the answer then is x is less than -4, because it's everything less than -4 is shaded. So less than is going to be an open circle here. And I'll take this and drag it, if it will allow me to do so. I was supposed to take it and drag it onto -4, but doesn't seem to want to budge here. Doesn't. Well, anyway, you're supposed to take it and drag it to -4, because x is less than -4. All right, let's move on to the next one here. Okay, Frank works at a convenience store. He earns $7.50 per hour when he works during the day. He earns $12.50 per hour when he works at night. He wants to earn at least $300 per week. So when it says at least $300, that means 300 or more. So you're looking for more, not less. So that's a clue to what we're looking for. So since it's more, at least 300 or more, so we can rule out A and B, because A and B would be less than. But you see that C and D are greater than. So we just need to figure out which one between C and D it will be. And this is how we'll do it. So he wants to earn at least $300 per week. If he works during the day, he gets $7.50 per hour. So let's just pull up Desmos real quick. If wants to make $300 and make $7.50 an hour, he'd have to work 40 hours if he only worked day hours, right? So what if he only worked night hours? So 300 divided by $12.50 that he earns, he'd only have to work 24 hours. So in order for him to earn a minimum of $300 per week, if he only worked day hours, he would do 40 hours or more. And if he only worked night hours, he would have to do 24 or more. So we need to look at the graph that has night hours at 24 or more and day hours at 40 or more. So let's move this out of the way real quick. All right, so here it looks like the number of hours during the day is 40 or more, and the number of night hours is 24. Well, yeah, it's C. It wouldn't be D, because D has it reversed. See, it has the day hours at 24 and the night hours at 40, so it's reversed. So it's C. All right, let's look at the next question. Okay, directions. Select the number that represents the region you want to select. Zach began graphing the system of inequalities shown. Y is greater than or equal to 2/3 x plus 1, and 5x plus 6y is less than or equal to negative 30. To complete the graph, Zach must shade the region which represents the solution set to the system of inequalities. What region of the graph needs to be shaded? Okay, well, why don't we just use DESMOS to find out for us, and why don't we just graph those? So the first one says y is greater than or equal to 2/3 x plus 1. And the next one says 5x plus 6y is less than or equal to negative 30. All right, so if we look at this graph here, the darkest section, which is right here, and I think if I look at this graph here, that's going to be section 2. Section 2, right there. Okay, and let me move this out of the way here. Yep, section 2. Yep, right there. That's what we saw on the graph. Yep, section 2. All right, let's look at the next question. Okay, drag the answers to the correct boxes. Each answer may be used more than one time. Using the inequality shown, create a system of two inequalities that could be represented by this graph. Alrighty then, so let's see, so y, it has a negative 1/2 x plus 2. Well, that must be this one because I see the plus 2 at the intersection, and then down 1 over 2. Down 1 over 2. So that's the negative 1/2. So with that line, as it being a solid line, which means equal, and then above, so that means y is greater than or equal to negative 1/2 x plus 2. So we'll put greater than or equal to. Excuse me. Now here we have 2x plus 5. Well, there's the plus 5 is, well, it's less than because it's shading everything less than. And it's a dashed line, so that means less than, no equal to. So that's going to be 2x plus 5 is, well, y is less than. Yep. Y, oops, excuse me. Let me correct myself here. Y is less than. And then let's just double check that on our DESMOS just to make sure that we do have the correct one. So we have y is greater than or equal to negative 1/2 x plus 2. All right, so we got that one. And then let's look at the next one. We have 2x plus 5 is greater than y. And yep, there it is, right there. Yep, so we have this correct here. All right, let's go on to the next question. All right, let f of x equals x and g of x equals 6x minus 1. Complete the statements to compare the graph of g of x to f of x. All right, let's just pull up DESMOS real quick again, and let's do some graphing. Now, f of x equals x. So, f of x equals x is simply just y equals x. Just a straight line right through the origin, diagonal line through the origin, I should say. And then g of x equals 6x minus 1. All right, so both of those there. So The graph of g of x is shifted, what are our answer choices? Up or down? Well, up, yeah, because since here is the original graph, and then this one, see that 6, that's, yeah, it's shifted up. Shifted up. The graph of g of x is steeper or less steep? Well, of course, yeah, it's steeper. Since we shifted it up, it's much steeper than this what fx equals x. So we have up and we have steeper. Yep, that's that one. Let's move on to the next question. All right, let f of x equals x. The graph of g of x is shown. Okay, so again, if we pull up DESMOS, to get rid of this here, see f of x, see that's straight through the origin here. And then it says the slope of g of x is, what are the answers here? Well, this slope is rise 1, run 1, rise 1, run 1, rise 1. So this is a slope of 1. Let's just check what the slope is here. So from the 2, we can go rise 1, and then 1, 2. So 1, 1, 2. So 1 over 2, 1/2. So this is 1. This is 1/2. So let's look at our options here. So the slope of g of x is 1/2 the slope of f of x. Get rid of this and see if there's anything else on here that they want us to do. Yes. And then the y-intercept is, let's see. Well, let's pull back up DESMOS. So the y-intercept is at 0 here. The y-intercept is 2 here. So then the question says the y-intercept of g of x is 2 more than, because f of x was at 0, it's 2. 2 more than. All right, so we have both of those answered. Let's move on. Okay, directions. Plot each point on the coordinate plane. A line will extend through the 2 points. Let f of x equals x or y equals x. And then the graph of g of x is shifted up 2 units from the graph of f of x and 3 times as steep as f of x. Plot 2 points to create a line that represents g of x. The coordinates of the points must be integers. Okay, so we want to plot 2 points here. All right. So we have our f of x equals x. Now, the graph of g of x, now, shifted up 2 units from the graph of f of x. So if it's shifted up 2 units, that's going to be a plus 2. Then it says 3 times as steep. So remember with the previous one, when it was at 6x, it was 6 times as steep. This time they wanted 3 times as steep. So what we will do is we'll take g of x equals 3x for 3 times as steep, and then shift it up 2 units plus 2. So 3x plus 2 is the equation for that. Then it says to plot 2 points to create a line that represents g of x. The coordinates must be integers. Okay, well that's simple. We're already here. All you do is hit the gear icon and hit that table icon, and there's a couple of points you can plot, 1 and 5 and 2 and 8. So let me just move this out of the way, and let me just do this here. So I can plot 1 and 5 right there, and then I could also plot 2 and 8 right there. And that's the graph. See, if we pull up the graph, yep, same thing. All right, so that was question 18. Let's go on to the next question. 19, a function f is described. F of x equals x minus 2 squared plus 3. The domain of f is all real numbers greater than 0. The range of f is all real numbers greater than or equal to would. Okay, well, let's pull this up in Desmos here. Let's erase all of this previous info. So we have f of x equals x minus 2. We put the squared in, plus 3. Plus 3. All right. So what do we see here? They're asking for the range. Now remember, domain means all x values, range means all y values. So for our y values, it looks like our y's begin at 3 and go up from there. So that means that the range of our y's are all numbers greater than or equal to 3. 3 and goes up, greater than or equal to 3. Right there. There's our answer. Next question. Okay. Select all the correct answers. Identify each function that has exactly 1, 0. All right. So let's go back and let's just graph each one and see. So 9x squared minus 4. Nope, that has 2 zeros. That one has 2 zeros, so that's not it. Let's look at the next one. 9 parentheses x minus 8. Okay. Yep, this one has exactly 1, 0. So I'll highlight that one. All right, let's look at the next one. So we have x squared plus 4x plus 8. That has no zeros. So that one's not it. Let's look at the next one. So we have x squared minus 8x plus 16. Oh, there's only 1 0 there. That one. And then finally, let's do negative 2, open parentheses, x plus 4, and then x plus 1. There are 2 zeros here, 2 zeros. All right, so that's not it. So it was the g of x, 9 parentheses x minus 8, and then the j of x, x squared minus 8x plus 16. Those are our 2 options. All right, let's look at the next one here. All right, directions, select all correct answers, identify each function that has an x-intercept of 3. Okay, well, let's go to our calculator, and let's put in this first one here. I'm going to put my division symbol. I'm going to put negative 4x plus 15 divided by 5. Okay, an x-intercept of 3. So 1, 2, 3. Nope, that's 3.75. So that one's not it. All right, let's try the next one. 3 minus 1/2 x squared. So that's a y-intercept of 3, but x-intercept of 2, almost 2.5. Almost 2.5. So that one's not it. All right. So let's take a look at the next one. 5/3 x minus 5. 5/3 x minus 5. And this one does have an x-intercept of 3, so I'm going to highlight that one. Okay, let's look at the next one. So we have x plus 3 and x minus 5. Okay, so we have an x-intercept of negative 3 and an x-intercept of positive 5, so that one's not it. And then let's try our last option. We have 3x squared minus 11x plus 6. All right, so we have 2/3, and 3. So this one has 3. So two options did have 3 as an x-intercept. All right, so we have those. Let's go on to the next question. Okay, let's look at question 22 here. Which table of values best represents the rule shown? The square of the sum of x and 5 is equal to y. All right, okay, let's pull out the calculator here. So the square of the sum of x and 5. So the sum of x and 5. So x plus 5. The sum of that, and then squared. The square of that amount is equal to my y. So I can put y equals, but we can see here. Anyway, we have it here. So this is the graph of the square of the sum of x and 5. Now, if I want to find out which one of these would be accurate for the table, I'm just going to hit my gear icon, my table icon here. Then, I'm going to just move this down a bit. And let me put in 3. Let's see what I get. For 3, I get 64. So it looks like it's going to be this one. Let me put in 4 just to see what's up. 4, I get 81. So there. C. That's what it is. That was simple. Okay, on to the next question. Okay, let's take a look at number 23 here. So let's see what it says. Plot each point on the grid. A function is represented by this rule. 1 more than 1/4 the square of a number x is y. Plot 3 points on the grid that are represented by this rule. Each point must have coordinates that are integers. Okay, well, let's open up DESMOS again. Let's get rid of all of this here. Add in here. All right, so what do we have? 1 more than 1/4 the square of a number x is y. So why don't I just work backwards? So y equals, now 1 more we know is going to be the plus 1. It says 1/4. 1/4 the square of a number. So x and then some number squared. And then plus 1. Plus 1. All right, so 1 more, which is the plus 1. 1 more than 1/4 the square of a number is y. Yep, so that's it right there. So y equals 1/4 x squared plus 1. Now, it says plot 3 points on the grid that are represented by this rule. Each point must have coordinates that are integers. All right, so in order to find those, we'll just go to the gear icon and we'll hit the table icon. So here we have 0, 1, we have 2, 2, we have -2, and 2. Let's see what happens if we put in 3. Nothing. What happens if we put in 4? 4. So there's another. So there's several. So let's just pick, all right, -2, 2, -2, 2, and then 2, and 2, and then 4, 5, 4, 5. There, that's 3 of them. Okay, on to question 24. Okay, so let's see. An experiment is conducted on a container of gas that is kept at a constant temperature. When the pressure on the gas is 30 pounds per square inch, the volume is 120 cubic inches. When the pressure on the gas is 40 pounds per square inch, the volume is 90 cubic inches. Let P represent the pressure on the gas. Let V represent the volume of the gas. Okay, let's see how I want to do this. Well, I'll just use this again really quick. All right, so we have volume and we have pressure. So volume and pressure. Okay, so let's see, what does it say? It says when the pressure on the gas is 30 pounds per square inch, The volume is 120 cubic inches. So the volume is 120 cubic inches when the pressure is 30 pounds per square inch. Okay, then when the pressure on the gas is 40 pounds per square inch, the volume is 90 cubic inches. So the volume will be 90 cubic inches when the pressure is 40. All right, so let's take a look at this relationship, because this looks like it has to do with variations. So we notice here our volume is decreasing while our pressure increases. So one is increasing and one is decreasing. Whenever we have that, we have what's known as inverse variation, because one is going opposite of the other. And then whenever we have inverse variation can be represented by y equals k over x, or as xy equals k. Now, in this particular scenario, since we have v and p here, so the volume is related equals k over pressure. So the volume or the pressure, or the pressure times the volume equals the k. Okay, so I just related the inverse variation formula to the pressure and volume which we have here. Now let's take a look at our answer choices and let's see if that helps us to answer this question. All right, so what do we have here? The volume of gas varies direct. Well, nope, it's not direct variation. So we can already rule out A and B because they're both saying direct variation. We already know it's inverse variation. So now let's see which one C or D is correct. The volume of gas varies inversely with the pressure because the volume is 4 times the pressure. Well, let's see. The volume is 4 times the pressure here, but the volume is not 4 times the pressure here. So it's not going to be C. So it has to be D, but let's just verify that. The volume of gas varies inversely with the pressure because the volume times the pressure is 3,600. Okay, well, let's 120 times 30. Let's see what that is. 120 times 30. That's 3,600. Okay. Then what else did we have? We had 90 times 40. All right, let's take a look at that. 90 times 40. Yep, they both say 3,600. So volume times pressure is 3,600. It's answer choice D. All right, let's look at question 25 here. All right, on to question 25. A relation is shown in this table. All right, we see the relation. Which statement about this relation is true? Okay, well, if we look at our x's are steadily increasing. Our y's are steadily decreasing. So if this one is increasing and this one is decreasing, that's inverse variation. So inverse variation, like we just learned, y equals k over x, or xy equals k. All right, so it's an inverse variation. So it's got to be either B or D because they both say inverse. It can't be direct, it's inverse. And then it can't be B. Why can it not be B? Remember when I mentioned that inverse variation is either y equals k over x or xy equals k. Here's an xy equals k, our k of 10. This is not in that form. And let's just see if it makes sense. X times y equals k. Well, x times y, 1 times 10 equals 10. 4 times 2.5 equals 10. 8 times 1.25 equals 10. 20 times 0.50 equals 10. So D, inverse variation, follows the form right here. All right, we're almost done. All right, let's see, directions. Plot each point on the grid. The coordinates of the points must be integers. The point shown is an element of the direct variation. Direct variation. Plot 2 points other than the point shown that are also elements of this direct variation. Okay, well, for direct variation, let me just put that under here. For direct variation, we know that the formula is y equals kx. Y equals k. And what do we also know about direct variation? It goes through the origin point, which is 0, 0. So, since we know that all direct variation equations go through the origin, that's one point we can easily plot right there. So that's one of our points, the origin, and then this point was already here. Then if we want to get another point, all we got to do is count the slope between the origin and this point, and then we can find another one. So our slope, we're going to rise 1, 2, 3, rise 3, run 2. So our slope is 3/2. So if I want another point, I will rise 1, 2, 3, run 2, 1, 2. There's another point. There you go, 2 additional points. Okay, let's look at the next one, 27. Using the quadratic curve of best fit, which equation most likely or most closely represents the set of data? All right, so let's pull up our DESMOS here. We're going to go to add item. We're going to add a table. So it looks like my x's are going to be -8, -7, -6, -5, 3, 5, 7. All right, so -8, -7, -6, -5, 3, 5, 7. Okay. And then I have for my y's 80.4, 57.8, 38.6, 22.8, 18.8, 51.8, 98.4. Alrighty, and let me just see something here. Okay, yeah, I just wanted to zoom out to see those. So this looks like, yep, quadratic curve of best fit. All right, well, the quadratic curve of best fit we will enter right here, which is y sub 1 tilde a x sub 1 and squared plus b x sub 1 plus c. All right, let me pull this down here. So what is it telling us here? Our confidence coefficient, correlation coefficient is 1. So it's saying that it's dead on. And if we look at the line, or the curve, I should say, it's hitting every single point. So it's dead on. So what is this telling us? That our curve of best fit is y equals 1.7x squared plus 2.9x minus 5.2. Oh, there it is right there. 1.7x squared plus 2.9x minus 5.2. Option D. There we go. All right, one more question. Let's see. This table shows the number of months used and the approximate distances driven in miles for 6 buses in the school district. Okay, so 6 miles, bus C this, bus that. Okay, using line of best fit. Which value is the best prediction of the distance driven in miles by a bus that has been used for 40 months? Okay, so let's pull up our calculator again, clear out our previous data. We're going to create a new table, add an item, add a table. So we have 6, 10, 12, 15, 20, 27. Those are our X values. And our Y values are 10,100, 17,000, 23,900, 31,500, 43,200, 59,900. Okay, so we've got all of those in, and now it's at line of best fit. And for line of best fit, that's going to be Y sub 1 tilde MX sub 1 plus B. All right, and scroll down, take a look here. So it's not exactly 1, but it's at 0.9986. That's almost 1, so that's almost dead on. So what this is telling you here, your line of best fit is 2,400 and Y equals 2,419.72X minus 5,362.44. So that is your line of best fit. So now, if we plug in that line of best fit here in our next line, Y equals 2,419.72X minus 5,362.44. And then we hit our gear icon and then our table icon. And then we come down off of our line of best fit, and it wants to know what, matter of fact, let me show you right here, where it says, which value is the best prediction of the distance driven in miles by a bus that has been used for 40 months. So we'll just come back over here to the tab, and we'll type in 40. So 91,426 miles. So let's look at our answer choices, and let's see what our answer choices say. 91,400. See? It told us right here, if I put the 40 back in. Oh, excuse me, not the 40 there. No problem. Come back. Right there, 40. 91,426. 91,400. Okay, so that's all of the questions here in the DESMOS TestNav here. So if you have any questions, talk to me in class. All right, have a good day. Talk with you later.